Welcome to our Data Warehouse Designer video tutorial. Prognoz platform provides a fully integrated toolkit that allows you to set up and customize data warehouses in order to perform business analysis tasks. Data Warehouse Designer supports relational, multidimensional, and file structures. Prognoz platform allows you to set up multidimensional data warehouses using the bottom-up or the top-down approaches. If you need to design data warehouse structure on your own, choose the bottom-up approach to create dictionaries, multidimensional cubes, and so on. The bottom-up approach provides for easy integration with other information systems without data duplication. Connect to external sources, such as accounting and management systems, to use provided data for creating dictionaries, cubes, and reports. If you use the top-down approach, a physical data structure is designed automatically. It allows users to create different repository objects without having to worry about physical structure implementation. When developing a data warehouse, you can combine these two approaches. Let's consider developing a data warehouse using the bottom-up approach. Data is physically stored in the form of relational structures on a database management system server. To access the data, let's create a database object. To create an object in Prognoz platform, you have to define its basic properties, such as name and identifier. The next page of the wizard allows you to override the database connection settings. Prognoz platform uses database object to connect to any modern database management systems. This allows easy integration with external systems data warehouses. Let's use the default parameters similar to repository connection property. Database management system server connection can be established automatically using login credentials. Upon wizard completion, the created database appears in the navigator. As mentioned before, at the physical level, Prognoz platform uses relational structures, tables. Let's create a new table named Countries. Prognoz platform objects have a list of parameters providing dynamic modification of their content. These parameters are defined on the corresponding wizard page. But in our case, we do not need them. Prognoz platform allows you to choose from 5 table types, each having specific settings. A table and view create the corresponding objects in the database. An attached table links an existing database table. It can be used to access data from another system. A query defines an SQL expression that is executed when the query is opened. An ODBC data source connects to external data source using an ODBC driver. Attached tables and ODBC data sources facilitate and speed up real-time data integration with other systems. Let's use the standard table. Specify the database for it. Then, add table fields. The key contains unique identifier of a territory. The name, the owner, that will be used to create a hierarchical dictionary based on this table, and the order. You can define type and constraints for each table field, including total length, null value support, and so on. Indices and a primary key can be used to speed up, select, and sort operations. Let's create an index based on the key field. Note that this index is the primary key of the table. Moreover, you can define a number of constraints and triggers, but in our case, we do not need them. We've created the countries table. You can input data into the table manually or load data using an ETL task. Prognoz platform allows you to create a number of different dictionaries. Table dictionaries are created using the bottom-up approach and customized manually. A table dictionary is built upon an existing table object. Table MDM dictionaries implement the top-down approach. When you create a table MDM dictionary, its physical data structure is created automatically. Moreover, Prognoz platform supports calendar dictionaries. Their structure and content are generated automatically based on the settings defined upon creation. This type of dictionary is used to process time-dependent data. Calculated dictionaries content is generated by a user-defined algorithm in the 4 language. Let's create a table dictionary of countries. Firstly, we need to specify dictionary attributes. The name, the identifier, and the order attributes are created by default. You can define additional attributes to implement hierarchy or control versions of dictionary elements. As we're going to create a hierarchical dictionary, let's add a new attribute named owner. Now, we can select the attributes and define their order for sorting the dictionary contents. The order attribute is selected by default. Now, define the dictionary structure by creating general and recursive blocks. General blocks are used for linear dictionaries, or if an exact number of hierarchy levels is known. If the number of hierarchy levels is not defined, recursive blocks are used. Add a recursive block to the dictionary and bind the primary key of the block to the identifier. Also, add a primary index to the dictionary. Dictionary indices are used for data binding when creating multidimensional cubes. Once the dictionary structure is defined, bind table fields to dictionary attributes. As the created block is recursive, let's define a recursion condition using Formula Editor. Specify the condition that defines the elements of the upper hierarchy level. Let's specify the elements with the owner attribute value equals null. Now, define the relation between child and parent elements using the owner field. The next stage requires you to specify the list of dictionary levels to be used in data aggregation. For hierarchical dictionaries, separate names can be specified for each hierarchy level. The following page allows you to define relations between parameters of the dictionary and objects it's based on. Such relations can also be defined for other composite repository objects. As we've not set parameters, close the wizard. The created dictionary is now available in the Navigator. As you can see, the structure of the dictionary is hierarchical, and it contains data from the countries table. Let's create a cube. Open the Data Sources folder and select the corresponding item in the Navigator menu. Specify the name and identifier of the cube. Prognoz platform supports 5 different cube types: a standard multi-dimensional cube, a view cube, obtained by fixing certain dimensions of source cube, a virtual cube obtained by combining several cubes, a calculated cube, which values are calculated according to their user set formulas based on the values of other cubes, and an automatic cube that is similar to a standard cube, but uses the top-down creation approach. Select the standard cube. Specify the cube facts. You can either define facts for each cube locally or use an existing dictionary. Define facts for the cube locally. To do so, create new fact named value. Once the list of cube facts is defined, they should be bound to corresponding table fields. For example, let's use the socioeconomic data table. Bind the value fact with the corresponding table field. Next, you need to specify the cube dimensions and bind dictionary's attributes to the table fields. For example, let us add the calendar dictionary to the list of dimensions. Once the dictionary is added, bind it to the data table. Let's use annual data. To do so, choose the primary index of the corresponding block of the calendar dictionary. Similarly, you can easily add indicators and countries dictionaries to the list of cube dimensions. Other wizard pages allow you to automatically convert factors to different units, customize relations and formulas for calculated cube facts, set up relations between cube parameters and its objects, aggregate cube data by levels of various dictionaries. For the purposes of our example, these properties are not necessary. So, finish the cube creation. To view the contents of the cube, use the OLAP analysis tool. Once dimension positions are specified and appropriate selections are made, the table shows the chosen data. This was a short overview of designing a data warehouse using the bottom-up approach. Creating data structures using the top-down approach is possible with the time series database. It's designed to manage and analyze statistical data. Unlike cubes, time series databases provide additional services such as data revision, validation, and transformation. To create a time series database, specify the NDN repository and dictionaries of measures and units. You can select existing dictionaries or create new ones. Further wizard pages allow you to define attributes and indices for the time series database. Create new country attribute, bound to the corresponding dictionary. Select necessary calendar levels. The internal structure of the time series database is created automatically. Now, data for analysis can be imported into the database. The created objects can be used when delivering Prognoz platform reports. Thus, Prognoz Platform Data Warehouse Designer allows you to easily create data warehouses of any architecture and complexity by creating data structure from scratch or by connecting to existing systems. Our Data Warehouse Designer video tutorial is over. Thank you for your attention.